A handful of numbers run the entire universe. They hide inside your phone, your bank account, the shape of galaxies, and the pattern of a sunflower. Nobody advertises them. We found them the way explorers find rivers. Some are ancient. One of them is so strange that knowing all of its digits is mathematically impossible. These are the constants of mathematics, and by the end of this video, you'll know what every single one of them actually means. Start with the most famous number on Earth. Take any circle. A coin, a wheel, a planet's orbit, divide the distance around it by the distance across it. You always get the same number, pi, any circle, anywhere in the universe. But here's what most people miss. Pi escaped geometry long ago. It shows up in the statistics of a coin toss, in the swing of a pendulum, in how sound waves add up, even in Einstein's equations for gravity. Why? Because anything that repeats, rotates, or oscillates secretly has a circle hiding inside it. Pi isn't really about circles. It's about anything that repeats. Now, a confession. Some mathematicians think we picked the wrong constant. Tau is simply 2 pi, the full turn instead of the half. Measure angles in tau and everything reads naturally. A quarter turn is a quarter tau. It's a civil war among mathematicians, fought half seriously with pastry puns. Tau Day, June 28th, answers Pi Day, March 14th. The lesson is subtle. The constants are discovered, but our choice of which one to name is human. And sometimes, we argue we chose wrong. Pi rules space. The next number rules time, everything that grows or decays. Put $1 in a bank at 100% yearly interest, and you get $2. Compound twice a year, $2.25. Monthly, about $2.61. Compound every second, and you approach but never pass 2.718. That wall is E. E appears wherever change feeds on itself. Populations, epidemics, radioactive decay, cooling coffee, compound debt. Its superpower, e to the x, is its own rate of change. Essentially, the only function that is its own derivative. Every other one is just a scaled copy. E is the mathematical signature of growth that feeds on itself. Next, the number that shouldn't exist. What times itself gives -1? For centuries, the answer was nothing. Mathematicians called it imaginary as an insult. The insult stuck. So did the number. The trick is to stop thinking amount and start thinking direction. Multiplying by I is a quarter-turn rotation. Multiply by it twice, a half-turn, and you're facing backwards, -1. Without I, there is no quantum mechanics, no electrical engineering, no signal in your phone. The imaginary number runs the real world, because I isn't a quantity, it's a rotation. The golden ratio. Cut a line so that the whole compared to the long piece equals the long piece compared to the short one. Only one number does it, phi, 1.618. Phi is the most irrational number. Of all numbers, it is the hardest to approximate with fractions, and that is precisely why sunflowers use it. Seeds packed at the golden angle never line up into rows, wasting no space. But honesty time, most claims about the golden ratio, in the Parthenon, in your face, in the stock market, are myths, pattern hunting after the fact. The sunflower is real. Most of the rest isn't. Phi's real power is being maximally awkward. Nature uses it precisely because it never, ever repeats. The square root of 2, the first number that broke mathematics. Draw a square 1 by 1. Its diagonal is root 2. The Pythagoreans believed every number was a fraction. Root 2 refuses. Provably, no fraction times itself gives 2. Legend says the man who discovered it was drowned at sea for it. A legend, the sources are murky, but the scandal was real. And it's in your pocket today. Every sheet of paper, from a 0 to a 4, has sides in ratio root 2. The only ratio that survives being folded in half unchanged. Root 2 proved that number is bigger than fraction, the first crack that opened modern mathematics. Now we enter stranger territory. Add up the harmonic series, 1 plus a half plus a third plus a quarter, and on forever. It grows without bound, but almost exactly like a logarithm. The gap between the sum and the logarithm settles down to a single number, gamma, 0.5772. Here's the scandal. After nearly 3 centuries, nobody knows if gamma is even a fraction. We know it to hundreds of billions of digits, and we cannot answer the simplest possible question about it. In mathematics, you can compute a number to absurd precision and still not know what it is. One of the newest universal constants was born in 1975, discovered with a pocket calculator. Take a population that grows and crashes and slowly turn up the intensity. First it's stable, then it oscillates between 2 values, then 4, then 8, then chaos. Feigenbaum measured how fast the doublings come. Each window is 4.669 times shorter than the last. Then came the shock. Any system that marches to chaos this way, swirling fluids, dripping taps, electronic circuits, uses the same 4.669. Even the road into chaos has a universal speed limit, and we found it in the 1970s, not in antiquity. Sum the cubes, 1 plus 1/8 plus 1/27, and on forever. You get 1.202. For squares, Euler found a beautiful answer, pi squared over 6. For cubes, 250 years of silence. Then, in 1978, Roger Apery, 61 years old and dismissed by his colleagues, proved the number is irrational. The proof was so unexpected that the room reacted with open disbelief. Many dismissed it on the spot. 2 months later it checked out. It stands. Apery's constant shows up in quantum electrodynamics, inside the calculation of the electron's magnetism, and in the physics of heat radiation. And still, nobody knows a closed form. One step from a solved problem can sit an unsolved one, for centuries. And finally, the number that ends mathematics. Pick a universal computer and feed it random programs. Omega is the probability that a random program eventually stops. One number per machine, not a single universal constant. For one famous machine, researchers fought their way to the first 64 bits in 2002. It begins 0.00787, and that is roughly where human knowledge of it ends. Because omega is provably uncomputable. Past some point, no computer program and no set of axioms can ever determine the next digit. Not, we haven't figured it out yet. Mathematics proves that no procedure ever can. The first digits of omega would settle the halting question for every small program there is. The whole number compresses infinitely many unsolvable problems into a single point on the number line. It is Gödel's incompleteness, written as a number. 10 numbers, a circle's whisper, growth feeding on itself, a rotation pretending to be impossible, nature's most awkward ratio, and at the end, a number that guards the edge of knowledge itself. Nobody chose them. They were here before us, and they will outlast everything we build. The universe, it turns out, has favorite numbers.